Okay, so can you please tell me about yourself and about your recent project?
Yeah, sure. So I have around 2.9 years of experience as a Java backend developer, and primarily I'm working with Java, Spring Boot, microservices, and RESTful APIs. And currently, I'm working with Mercedes-Benz, where I'm involved in developing and maintaining a scalable backend applications and support like various business operations. So in my current project, I work extensively on designing and developing microservices using Spring Boot, and my responsibilities basically include implementing business requirements, developing RESTful APIs, and integrating with external services. Apart from that, I also work with databases like MySQL and use the Spring Data JPA for data access. Apart from backend development, I have hands-on experience with cloud services and AWS, including S3 for object storage and ECS for the containerized deployments. And I also have experience on code pipelines building for like through CI/CD pipelines and automation. And for API testing and validation, I regularly use Postman. And while GitHub that is used for the version control, and for we use Jira for sprint planning and task tracking and influence, and we use Confluence for project documentation. And I have been working in an agile environment throughout my career. So I actively participate in sprint planning and daily stand-up calls and code reviews and retrospective meetings. So like yeah, so these experiences have like they have helped me to develop a strong problem solving skill, and also like a good understanding of software development and best practices, and the ability to collaborate effectively with cross functional teams. So yeah, so this is what is about all about my experience. And
Okay, that's fine, but can you tell me what exactly is your current project?
yeah, so currently I'm working on a vehicle connectivity and customer service platform for Mercedes-Benz. And the primary objective of the project is to provide a centralized backend system. So that basically enables customers and internal applications to access vehicle related information and services in real time. And the platform consists of multiple microservices developed using Java and Spring Boot. And these services handle functionalities such as customer profile management, vehicle registration, service history, maintenance reminders, notification management, and there are also various other types of microservices are there. So basically, we expose REST APIs that are consumed by the web and mobile applications. So these are used by the customers as well as the internal business teams. So in all of this, my responsibility is to include the developing new microservices and enhance the existing APIs as well. And also, I involve in fixing the production related issues. And I have also worked on the optimization of the application performance, and I am involved in the complete software development life cycle, like from requirement gathering analysis to design discussion, and again to development and testing and deployment. So I have been involved all throughout the whole life cycle of the software development. And for data persistence, we use MySQL and log with the Spring Data JP, and we also use AWS services like S3 for document storage and ECS for containerized application deployment. So yeah, so this application basically follows the microservices architecture, and it allows the different modules to scale independently. And we also implement security using the Auth2 and JWT based authentication to ensure that only authorized users can access the specific resources. So yeah, so this is what is all about the my current project I'm working on. Yeah.
Okay, good. So, can you tell me what kind of optimization you have performed in your project?
Yeah, so in my current project, I have worked on several performance optimization initiatives at both application and database levels. So one major optimization I have worked on, so that is involved in database query tuning. So we identified certain APIs that were taking like more than 4 or 5 seconds to respond. So that was taking that much of time because they were fetching the unnecessary data and performing multiple databases calls. And we analyzed the SQL queries and added appropriate indexes on frequent searches columns and modified the queries to fetch only the required fields. And apart from that, another optimization I would say, like I worked on the implementing the pagination for APIs that return the large data sets. So earlier it was doing that. So instead of loading the thousands of records at once, we introduced like pageable response. So that improved the performance and reduce the memory consumption. And also apart from that, I have introduced caching for relatively static data, so like such as configuration and reference information or any kind of database which does not gets updated frequently, so we can use the cached mechanism for that. So yeah, so these kind of optimizations mostly I have worked on.
Okay, so how do you decide when indexing is required? Because you said that you have used appropriate indexing, right? So what is the meaning of that and how you have used it?
Yeah, so we don't randomly add indexes. So first we identify like slow queries either from the application logs or the tools or any logs like slow query logs. So if anything like that has been reported, like some query is taking lots of time. So in that we first analyze the SQL query and look at the execution plan using the like commands like explain, for example in MySQL. So like if the database is performing a full table scan and the table contains a large amount of data, then that's usually an like indication that an index may help in that case. So after that we then look at the columns frequently used in where, join, order by or group by clause, and consider like creating indexes on those columns. And after creating the indexes, we again check the execution plan and complete query execution times to verify that like index actually that improved the performance or not. And if it has improved, then only we say go ahead for that specific query. So let's say for example, let's say we have any let's say any customer table is there, okay, and it has various fields like columns, you can say, let's say like ID, name, email, like CT. So all those details are there. And suppose we are querying something like select a star from customer where email equal to, let's say, any email is there, okay. So if the table contains, let's say, 10 million records and email is not indexed, then MySQL may scan all rows, okay, in that case. So that is definitely going to take lots of time. So instead of that, what we can do, that we can create the indexing on the that email column, okay. So we can like say like create index that on that customer email column, okay. So after that, once we make the same query, it is definitely going to take the lesser time if we have done the indexing properly. So yeah, so we can compare the time now, like how much time it was taking earlier and how much time it is taking now, and based on that, now we can decide like, okay, the indexing whatever we are thinking that is good, and we can go ahead with that. So yeah, that is how we decide. Yeah.
So is there any kind of side effect is also there of using indexing?
Yeah, so like yes, so indexing improves the read performance, but it adds the overhead of writing operations such as like if we are doing insert, update, or delete any these queries, then indexing is like kind of costly in that cases, because index also needs to be updated at that point of time. So excessive indexing can increase the storage uses, and it can slow down the write heavy application. But yeah, so if the that much of a deletion, frequent deletion, insertion is not going to happen, in that case yes, we can use that. Otherwise we have to like avoid that, and we have to see like how we can use that. There are other ways also, like partitioning and all also can be done, but yeah, it all depends on the scenario and situation, how and what we need to do. Yeah.
Okay, so can you tell me what is n plus 1 query problem?
Yeah, so n plus one query problem is a common performance issue that occurs when an application executes one query to fetch parent records and then executes additional queries for each parent record to fetch the related child data. So, for example, if we fetch, let's say, 100 orders using a single query and then execute a separate query for each order to retrieve its order items, then the application ends up like executing 101 queries in total, so 1 plus 100 like that. So this kind of significantly increases the database round trips and can like degrade the application performance. So especially when like dealing with large data sets, so it affects a lot. So in Spring Data JPA, this problem often occurs because of the lazy loading of associated entities. So to resolve this, like we can use techniques such as like fetch join or entity graphs, and there are other techniques also. So yeah, so in one of my project we identified an API suffering from this issue, this n plus one problem, through query logs, and optimized it using the fetch join. So that basically reduced the number of databases calls and improved the API response time like very much significantly. So yeah.
Okay, so can we use SQL and NoSQL databases together? Is it possible?
Yeah, so yes, we it is possible. So in one of my projects, like we had requirement to handle like both structured and unstructured data efficiently. So we used a combination of SQL and NoSQL databases. So for highly structured data, like such as customer information, vehicle detail, or user accounts. So for those kind of things, we used MySQL because it provides a strong consistency. And for the data which was more flexible is nature, such as like kind of notification, user preferences, application logs, and event related information. So for that, we used like NoSQL databases like MongoDB. So since the structure of this data could evolve over time and did not require complex relational queries. So MongoDB basically provided better flexibility and scalability in that case. So yeah, so in the application layer, we maintained separate repositories and configurations for both databases. So that allows like each service to interact with the appropriate data store and based on the business requirement. So yeah, so this hybrid approach helped us to leverage the strength of both SQL and NoSQL databases while maintaining the good performance. So yeah.
Okay, so can you tell me the difference between authentication and authorization?
Yeah, sure. So authentication and authorization, like they both are interrelated concepts. So authentication is the process of verifying a user's identity and ensuring that the person trying to access the system is like genuinely who they claim to be. And this is basically typically done using the credentials such as like username and password, and also sometimes using OTP or biometric or JWT token. So once the user identity has been successfully verified, then the next step is authorization. And authorization basically determines like what resources or functionalities or data that the authenticated user is allowed to access. So all the users are not supposed to be access all the URLs. So let's say, for example, in an enterprise application, like both an admin and regular user may successfully authenticate and log to the system. However, based on their roles and permission, the admin may be authorized to create, update, and delete records, while the regular user may only have permission to view the item. Okay, so yeah, so that's what like authorization decides. Like so in simple words, we can say like authentication means like kind of who are you, and where authorization means like what are you allowed to access or do. So that's the difference between these two.
Okay, so you have worked on JWT, right?
Yeah, I have worked on that.
Okay, so can you tell me complete flow of JWT, like it has how many parts, session, token generation, refresh token, everything. Can you tell me?
Yeah, sure. Yeah, so this JWT basically consists of three parts. So it has header, payload, and signature. So the header contains the information about the token type and like signing algorithm, and payload contains the claims such as like user ID, username, roles, permissions, and signature is used to verify that the token has not been modified. Okay, so these are the three parts. So these three parts are base 64 encoded and separated by dots. So the complete flow starts when the user attempts to log in by providing credentials such as username, password, and the authentication service validates these credentials against the databases and an identity provider, and if the credentials are valid, then server generates the access token. And in most modern system, a refresh token as well is generated. Okay, so the access token contains user information and roles, and is digitally signed using the secret key or private key. Okay, so the token is then sent back to the client application, and the client stores the access token typically in memory or as a secure cookie, and includes it in the authorization header and as a mirror token for every subsequent request. So when a request reaches the backend service, then a security filter intercepts the request, extracts the JWT and verifies the signature and checks like whether it has expired and validates the claims inside the token. So if the token is valid now, then the again user is authenticated and the roles present in the token are used for authorization decision. So like for example, user with the admin role may have allowed the to access the administrative APIs, while the regular users may have the restricted access. Okay, so this is done till now, and then unlike traditional session based authentication, JWT authentication is stateless. So in session based authentication, the server stores user session information in memory or like in a database. Okay, so the server like must look up the session data for every request, and with JWT, the token itself contains the required user information. So the server does not need to maintain the session state. Okay, and since access tokens are usually short lived for the security reasons, so they are configured with the relatively small expiration time, such as like maybe 15 minutes to 1 hour. Okay, and if the access token expires, then the user should not be forced to log in again immediately. So this is where the refresh token comes into the play. Okay, and the refresh token has a much longer validity period, such as like several days or weeks. So when the access token expires, the client sends a refresh token to the dedicated refresh endpoints, and the server validates the refresh token, and if the it is still valid, then it generates the new access token without requiring the user to re-enter the credentials. So till the refresh token is valid, we don't have to again re-enter the credential. Okay, and if the refresh token has also expired, or the access has been revoked, then user must authenticate again. So that is how the whole flow goes on.
Okay, can you tell me how does Spring Boot auto configuration works?
Yeah, Spring Boot auto configuration is a feature that automatically configures the application based on the dependencies available in the project's class path and the configuration properties provided by the developer. Okay, so when a Spring Boot application starts, then it scans the dependencies present in the pom.xml file and determines like what components need to be configured. So, for example, if the Spring Data JPA dependency is present, then Spring Boot automatically configures the data source, entity manager, and the transaction manager and JP related bins. Okay, and similarly, if the Spring Web dependency is included, then it configures the component requires for the building REST APIs such as embedded Tomcat server, Spring MVC infrastructure, and all. So we don't have to explicitly add these dependencies. So this behavior is primarily enabled through the at the rate of Spring Boot application annotation. So that internally includes like we have annotations like enable auto configuration. Then we have at the rate of conditional on class, conditional on missing bean, conditional on property. So these are there to decide whether a particular configuration should be applied or not. So like as a result, like developer can focus only on writing the business logic rather than spending time on like extensive manual configuration. So that actually significantly reduces the boilerplate code and speeds up the application development. So yeah, so that is how yeah.
Okay, so how does Spring Boot know like which auto configurations to load?
Yeah, so Spring Boot reads a configuration class listed in like I think in Meta INF we have Spring Boot auto configuration imports. So that evaluates conditional annotation and loads only the configurations whose conditions are satisfied.
Okay, and how does Spring decides which bin to create?
Yeah, Spring decides which bin to create primarily through the component scanning and the configuration classes. So when a Spring Boot application starts, then at that of Spring Boot application annotation triggers component scanning from the package where the main application class is located, and Spring scans the package and its sub packages for the classes annotated with stereotypes like we have added of component, add service, add repository, add controller and all. So once these classes are identified, then Spring creates a bin definition for them and registers them in the application context. So that acts as the Spring IOC container. And in additional to that, it also scans like anywhere, like add date of bean annotation or add date of configuration is there. So these classes are also scanned. And during the application startup, Spring resolves dependencies between the beans and injects them wherever required using the constructor injection, setter injection, or whatever kind of injection we have taken. So this process basically ensures that all required objects are managed by the Spring container and are available like throughout the application life cycle.
Okay, so can you tell me about the Spring Bean life cycle?
Yeah, Spring Bean life cycle refers to the stage bean goes through from the creation to destruction within the Spring container. So when the application starts, then Spring identifies bean definitions and creates bean instances. And it then injects all required dependencies using the constructor, setter, or field injection. And after dependency injection, initialization methods such as like those annotation those which I annotated with the add data post constructor add data post construct are executed, and that allows any setup logic to run. So this bean is then ready to be used throughout the application. And when the application shuts down, then Spring invokes the cleanup method, such as like those annotated with pre-destroy annotation to release resources and perform any necessary cleanup. So yeah, so in summary, the life cycle consists of beans initialization, dependency injection, and initialization, uses and destruction. So this is what is the whole Spring Bean life cycle.
Okay, tell me again what is post construct and pre destroy?
Yeah, post construct basically runs initialization logic after bean creation, and pre-destroy runs cleanup logic before bean destruction. So that's the difference.
Okay, so can you tell me why constructor injection is best?
Yeah, constructor injection is generally considered the best dependency injection approach in Spring because like it promotes immutability and makes dependencies mandatory and improves the testability. Okay, so when dependencies are injected through the constructor, an object cannot be created without providing all the required dependencies. So that ensures that the bean is always in the valid state. And since the dependencies can be declared as final, then they cannot be modified after object creation, which improves the code safety and maintainability. So constructor injection also makes unit testing easier because like mock objects can be passed directly through the constructor without requiring the Spring container and all. Okay, so additionally, like it clearly shows like all the dependencies a class requires, making the code more readable and easier to understand. So yeah, so these are the reasons why constructor injection generally preferred over the like field injection or setter injection.
Okay, so how would you investigate slow REST API response under any load?
Yeah, so if a Spring Boot REST API starts experiencing slow response under any heavy load, then our first step would be like to identify the bottleneck rather than like making any kind of assumption. So I would begin by analyzing application logs and monitoring CPU and memory utilization and reviewing the metrics from the tools like Spring Actuator and all. Next, I would like examine the database layer as slow or optimized queries are often the primary cause of the performance issue. Then I would use query analysis tool and execution plans to identify full table scan and add appropriate indexes wherever necessary. And we will also try to optimize the query wherever required. And apart from that, if the API is returning suppose large amount of data, then we would implement the pagination to reduce the response size and memory consumption. So and for frequently accessed data, we can consider like introducing caching to minimizing the repeated database calls. And I would also review like synchronous operations and move non-critical tasks such as like notification or audit logging to asynchronous processing wherever appropriate. So yeah, so these kind of steps we can take to analyze and investigate any kind of slowness in the REST APIs.
Okay, so what is circular dependency and how can you resolve it?
Yeah, circular dependency occurs when two or more Spring Bean dependencies on each other. I mean, they depend on each other directly or indirectly, and that create a cycle. Then we say it is as a circular dependency. For example, suppose if Bean A requires a Bean B to be created, and again B further requires Bean AB to be created. So Spring cannot determine like which bean should be instantiated first. So this ultimately leads to the circular dependency issue. Okay, so to resolve this issue, like one approach is to use a setter injection instead of constructor injection, as it allows Spring to create the beans first and inject the dependencies later. And another common solution is to use add rate of lazy annotation on one of the dependencies, so which delays the beans initialization until it is actually needed. Okay, like so this is one of the, we can say, like one technique we can say we can use that. However, the best long term solution is usually to redesign the application and remove the circular dependency itself. Okay, so no, usually we should redesign it, not just by doing the at the rate of lazy and all. So that is not a permanent solution for that. So yeah, so that is what is the circular dependency.
Okay, why does constructor injection fail with circular dependencies?
Yeah, because Spring must create all constructor dependencies before creating the bean itself. So if a bean needs bean B, okay, so suppose any bean A is there and that needs the bean B, and again the bean B needs bean A, then Spring gets stuck in a loop and cannot instantiate like either bean. So that ultimately results in a bean currently like in creation exception bean. Okay, so setter injection can sometimes avoid this because like bean creation and dependency injection happens in separate steps. So yeah, so that is why the constructor injection fails with the circular dependencies.
Okay, so can you explain me how can you shorten the URL or how do you design?
Yeah, to design the URL shortener, we would maintain a mapping between the original long URL and a generated short URL in a database. So typically the table would contain the fields such as like unique ID, the original URL and the sorted URL, shortened URL. So the system generates a unique identifier, often using the techniques such as like base 64 encoding, and converts it into the short code. Okay, and this short code is appended to the application's domain to create the shortened URL. So when the user accesses the shortened URL, then application looks up the corresponding original URL from the mapping table and redirects the user to the actual destination. So yeah, so that is how we can design the URL shortener.
Okay, so can you tell me can a static method be overridden?
No, a static method cannot be overridden because like it belongs to the class rather than an object instance. So methods overriding relies on runtime polymorphism, where the method to be executed is determined at runtime based on the actual object type. So since static methods are resolved at compile time using the class references, so they do not participate at in runtime polymorphism. So if a subclass defines a static method with the same signature as its parent class, then it is known as the method hiding rather than the method overriding. So yeah.
Okay, and what is double checked locking in singleton?
Yeah, double checked locking is a technique used to implement a thread safe singleton while minimizing the performance overhead of synchronization. So in this approach, the singleton instances is checked for null before entering the synchronized block, and then checked again inside the synchronized block before creating the object. Okay, so the first check avoids like any kind of unnecessary synchronization once the instance has already been created. So while the second check ensures that only one thread creates the instance when multiple threads attempt to access it simultaneously. Okay. So this approach basically improves the performance compared to the synchronizing the entire method while still maintaining the thread safety. So yeah, so that is what double check logging is in the singleton.
And what do you think the best way to implement the singleton?
Yeah, the best way to implement the singleton design pattern in Java is by using an enum, I think. So enum based singletons are inherently thread safe because the JVM guarantees that an enum instance is created only once, and they are also protected against the common issues such as reflection attacks or serialization and deserialization problems. So yeah, so due to their simplicity, reliability and built-in thread safety, enum based singletons are generally considered the most robust way to implement the singleton pattern in Java. So yeah.
Okay, so do you know what is the difference between public and private methods in at the rate of transactional annotation? So can we use private methods in transactional?
Yeah, so the transactional annotation in Spring Boot is used to manage the database transactions and ensure the data consistency. However, like it works only when the annotated method is invoked through the Spring managed proxy. So when at the rate of transactional is applied to a public method, then Spring's AOP proxy can intercept the method call and start a transaction before execution, and either commit a rollback and the transaction based on the outcome. On the other hand, if like transactional is applied to a private method, then it does not work because like private methods cannot be intercepted by Spring proxy mechanism. And since the call to the private method happens internally within the same class, so it bypasses the proxy entirely. Okay, and no transaction management is applied. So therefore, in Spring application, at transactional should typically be placed on the public methods only. Okay, and we should not be having the private methods in that.
Okay, so can the class be loaded twice? So same class can be loaded twice with different class loaders?
Yeah, the same class can be loaded multiple times by different class loader instances. So in Java, a class is uniquely identified not only by its fully qualified name but also by the class loader that loaded it. Okay. As a result, like if two different class loaders load the same class file, then the JVM treats them as like two separate classes. So this behavior is commonly used in application servers, plugin architectures, and modular system where different application or modular modules need to load their own version of the same class without conflicts. So yeah.
Okay, and what is parent delegation model?
Yeah, the parent delegation model is the mechanism used by Java class loaders to load classes. So when a class loader receives a request to load a class, then it first delegates the request to its parent class loader instead of attempting to load the class itself. So the parent continues this delegation chain until the bootstrap class loader is reached. So only if the parent class loader cannot find the requested class does the child class loader attempted to load it. Okay, so this model prevents the duplicate class loading and ensures that core Java classes are loaded by trusted class loaders, providing both consistency and security.
Okay, so can you tell me how do you design an immutable class with a mutable list?
Yeah, to design the immutable class that contains a mutable object such as list, the class should be declared as final first of all, so that it cannot be extended, and all fields should be private and final, and no setter method should be provided. Okay, so the mutable list should be initialized through the constructor, and instead of storing the original list reference directly, a defensive copy should be created. Okay, and similarly, when returning the list through the getter method, again a copy or an unmodifiable version of the list should be returned rather than the actual internal list. So yeah, so this ultimately ensures that the external code cannot modify the internal state of the object, and thereby it preserves the immutability.
Okay, and can you tell me if the constructors can be private?
Yeah, constructors can be private in Java. So a private constructor prevents objects of the class from being created outside of the class itself. So private constructors are commonly used in design patterns such as singleton, like where only one instance of a class should exist, and in utility classes where object creation is not required. So, yeah, so by making the constructor private, the developer gains the complete control over how instances of the class are created and managed. So, yeah, it can be private.
Okay, and can a class implement multiple interfaces but extend only one abstract class? Is it possible?
Yeah, so a Java class can implement multiple interfaces while extending only one abstract class. So Java supports multiple inheritance through the interfaces, allowing a class to inherit behavior from multiple sources. However, Java does not support multiple inheritance of classes to avoid ambiguity issues such as the diamond problem. So therefore, a class can extend a single abstract class to inherit a common functionality and at the same time implement multiple interfaces to provide additional behaviors and contracts. So yeah.
Okay, and how about can a functional interface extend another interface?
Yeah, it can. So yes, a functional interface can extend another interface. So provided that the resulting interface still contains the exactly one abstract method. Okay, so that's the main thing. So if the parent interface introduces additional abstract method that causes the total count of abstract method to exceed one, then interface will no longer qualify the functional interface. Okay, so the default methods and static methods do not affect the functional interface contract because only abstract methods are considered when determining whether the interface is functional or not. So yeah, so it can be, but it should satisfy this rule.
Okay, and what is the difference between process and thread?
Yeah, a process is an independent execution unit that has its own memory space, a system resource, and execution environment. So, an application running on a computer is typically represented as a process. So, a thread, on other hand, is the smallest unit of the execution within the process. Okay, so multiple threads can exist within the same process and share the process memory and resources while executing different tasks concurrently, because like threads share resources, communication between them is faster than communication between processes. So yeah, so processes provide better isolation and fault tolerance, whereas threads are more lightweight and efficient for performing parallel tasks within an application.